Hi, I am M. Jagadish, Associate Professor in CSC Department. In this session, we discuss about type of inheritance. In the previous session, we discussed what actually inheritance is. Now in this, we discuss about types of inheritances. Basically, there are 5 types of inheritances named as single inheritance, multi-level inheritance, multiple inheritance, hybrid inheritance, and hierarchical inheritance. Come to the first one, that is nothing but single class inheritance or simply single inheritance. In this single inheritance, we just go to specify that in this there is only one base class and only one derived class. So base class is nothing but here employee and derived class is nothing but manager. There are two classes in this one. One is the employee class and one more is nothing but manager class. So in this, the class manager is deriving from the class employee. So when one class is deriving from one more class, then we can call that is nothing but simply inheritance, or we can call single inheritance. There is only one base class and only one derived class. We can also call the base class with one more name, that is nothing but super class, and we can also call the derived class with one more name, that is nothing but subclass. When we derive one class from one more class, that indicates the properties of base class will be there in properties of derived class. So the class manager consists both the properties of the manager class and also the properties of employee class. So this is nothing much single class inheritance or simply inheritance. Now come to the next one, multi-level inheritance. Multi-level inheritance, that indicates here multiple levels are there in order to derive one class from another class. And one more thing, when we just go to specify the multi-level inheritance, we just go to specify that we are going to derive a new class from already derived class. We are deriving a new class from already derived class means here totally we have 3 classes named as class A, class B, class C. Now when we specify, there are 3 classes named as class A, class B, class C. Here we are deriving a new class, that is class C, from class B, and this class B is nothing but already derived class from class A. So when we are deriving a new class from already derived class, we can call this particular one is nothing but multi-level inheritance. And come to the next one, that is nothing but multiple inheritance. In this multiple inheritance, whenever we are deriving a new class from more than one class, then we can call that is nothing but multiple inheritance. Here the base class may be a 1 or 2 or 3. If it is 1, it comes under the only single inheritance. If it is more than 1, means 2 or 3 or 4, then it comes under multiple inheritance. We are deriving a new class from multiple base classes. When we are deriving a new class from multiple base classes, then we can call that is nothing but multiple inheritance. That indicates here in the class A, we have the properties of class A and also the properties of class B. Whatever the data members and data functions of class A and class B will also be there in class C. This is nothing but multiple inheritance. And then come to the next one, hierarchical inheritance. This hierarchical inheritance is nothing but reverse to the previous. That indicates it looks like an inverted tree. In this particular one, there will be only one base class, and we are going to derive a multiple derived classes from a single base class. When we are deriving multiple derived classes from a single base class, then we can call that particular one is nothing but hierarchical inheritance. Totally here class A, class B, class C, class D are there. In this, class A acts as the base class and class B, class B, class C are acts as the derived classes. So class B is deriving from class A, and also class D is deriving from class A, and also class C is deriving from class A. So likewise, in this particular one, we are going to derive multiple classes from a single base class. If it is like so, then we can call that particular one is nothing but hierarchical inheritances. Then come to the next one, hybrid inheritance. In this hybrid inheritance, the name itself indicates hybrid. It is nothing but mixture. So we just go to specify that in the hybrid inheritance, there is a mixture of number of inheritances. Like we can go to specify the combination of multiple inheritance and multi-level inheritance, or the combination of hierarchical inheritance and multiple inheritance. So like that, we go to specify the combination of any two inheritances, then it generates as a hybrid inheritance. But there is a problem with this hybrid inheritance. Why? Because means if at all, if we go to work with hybrid inheritance, then we can get same function name from multiple number of clauses. If we get same function name from multiple number of clauses, then the compiler generates the error. It will be in confusion state. The compiler will be in confusion state, which function to execute or how to use the function. So whenever if it is like so, then automatically the ambiguity situation will comes into the picture. If it generates the errors related to this one, then there is an ambiguity to select the function. Then this ambiguity problem can be solved by means of one more thing, that is nothing but virtual base class. We'll discuss this virtual base class in the upcoming session. So this is nothing but hybrid inheritance. Then come to the next one, access specifiers. When we are working with the inheritance, then definitely we must also consider the access specifiers. And those access specifiers we already know. Among those two we already know, those are nothing but private and public when we discuss about class. So we already know what actually private means. If at all, if the data or if the variable or if the data member is declared as a private, then that particular data or a member function or a variable which is declared as a private will be accessible by only the member functions of the class. Outside of the member functions cannot access the member functions or the data members which are declared in private section. So even if you are not declared anything, any access specifier, if you are not specified in the class, then automatically by default that particular one will comes under private. So this is nothing but private access specifier, we already know. Then come to the next one, public. So in the class there is a one more access specifier we can specify, that is nothing but public. When we declare or define the data functions or the member functions and data members under the public access specifier, then these data members or the member functions can also be accessed from outside of the class. Outside of the class also. So in order to access the data member functions or simply the member functions which are declared under the public mode, then we just go to use of instance of the class. That is nothing but object of the class. We just go to create the object. By using of the object, you can access the member functions in the class which are declared under public mode. This is nothing but public access specifier. And apart from these two things, we also have one more, that is nothing but protected. This public and private we already used when we discussed about class. Now here we discuss about one more, that is nothing but protected. So in some cases it is required to make use of a new access specifier, that is nothing but protected access specifier. This protected access specifier can also be accessible by the class, can also be accessible by its subclass. When we declare data members or a data functions by means of protected access specifier, then you can access by its subclass. Now how we just go to access, in which manner this protected access specifier will affect. See, protected access specifier, when we specify the protected access specifier, the members under the protected access specifier will be private whenever the child class is derived in private inheritance. It will be in public when the child class is derived in public. It will be under protected when the child class will be derived in protected inheritance. So based on the way or based on the type, it is deriving that protected access specifier may act as either private or protected or public. So totally we have three access specifiers. Those are nothing but protected access specifier, private and public access specifiers. So the first one is nothing but private inheritance. That is nothing but we are going to inherit we are going to inherit the derived class. We are just go to derive a derived class in private modes. Now look at this. We are going to specify that inherit as a private. So when we just go to derive a new class in a private mode, then how it reflects, what data members will comes under the derived class and how it will be affected. Assume that, look at this, we have two things. One is a base class and one more is a derived class. In the base class, we have a three sections: private section, protected section, and public section. When we derive a new class under the private mode, then the private members will not be accessible in the derived class. The private members will be there to base classes only, and protected members will comes under private modes or private section in the derived class. Similarly, public members will also comes under private section in the derived class when we are deriving a new class in private modes. Similarly, look at one more. What happens when we inherit as protected? See, when we inherit as a protected, same thing. There are two classes, base and derived, and three sections: private, protected, public. How it reflects whenever we are deriving a new class in protected mode. As usual, the private members will be there in base class only. It will not be accessible in derived class. And when we are deriving a new class in protected mode, the protected members of the base class will be under the protected mode of derived class. And similarly, the public members of the base class will be under the protected members of derived class. That indicates both protected and public members will be under protected section of derived class. Then come to the last one, that is nothing but public. What happens when we derive a new class under the public mode? Again, same thing. There are two classes, base and derived, and three sections: private, public, and protected. As usual, the private members of the base class will never be accessible from derived class, so it is inaccessible. And the protected members of the base class will comes under protected members of the derived class, and public members of the base class will comes under the public members of the derived class. When we inherit a new class or when we derive a new class under the public mode, then both protected members and public members will comes under protected members and public members. The protected members will comes under the protected members and public members will comes under the public members of derived class. So this is the way how we just go to specify the deriving of a new class in public modes. And these are the ways of as a specifiers how it reflects to inheritance. Thank you.